Hey, we're going to talk about the distance formula today, and we're also going to talk about the Pythagorean theorem. Um, they're they're kind of the same thing. The distance formula is derived from the Pythagorean theorem, but we're going to talk about it first. When we're finding distance, well, we can use distance to find length. They're basically interchangeable. So you can think of this as the length formula if you want. Okay, and what else do I want to say? Oh, length and distance. You're going to love this. They're always going to be positive. Okay, that should make some of you smile. Okay, so we have this formula and it's kind of scary and it looks like, well, it's got this crazy square root in it. And what that comes from is the Pythagorean theorem where we have this c squared. Well, once we find c squared, we have to find the square root of c squared, which is c. So that's what the distance formula does. It takes that square root for us. Okay, so let's see this in action. We are going to use the distance formula to find FG and JK and then decide if they're congruent. If they're congruent, their measures should be the same. So if these are congruent, then FG should equal JK. If the segments are congruent, the measures are equal. So I have to pick my x sub 1 and y sub 1 and x sub 2 and y sub 2. So let's start with FG and let's start with FG. So for FG, my x sub 1, okay, that's the point 1, 2. Here, let's do it like this. F 1, 2. And G is, what is that? 5, 5. Okay, so let's say this is our x sub 1, this is x sub 2, this is, just kidding, that's y sub 1. Okay, this is x sub 2 and y sub 2. So we're just going to plug these in. So the distance equals the square root of my x sub 2, which is 5, minus my x sub 1, which is 1, and I have to square it, plus my y sub 2, which is also 5, minus my y sub 1, which is 2, and I have to square it. Okay, now I just have to simplify a little bit. So PEMDAS says that I have to simplify in parentheses first. So this turns into a 4, and this turns into a 3. So my distance equals the square root of 4 squared plus 3 squared. Now I can simplify a little bit more. I know that 4 squared is 16, and 3 squared is 9. So 16 plus 9 is 25. So my distance is, let's go this way, the square root of 25, which is 5. 25 is a perfect square. So my FG was 5, my length of FG, segment FG. Okay, so now I have to do the other one. Okay, J is negative 4, 0. And K is negative 1, negative 3. Okay, I'm going to plug those into the distance formula. I'm going to go this way because I kind of am running out of room over there. So my distance equals, oh, let's label my stuff. Here's my x sub 1, y sub 1, x sub 2, y sub 2. So my distance is okay. My -3 minus 0 squared plus my -1 minus -4. If I do minus and negative, I get plus. Okay, let's do a little bit of simplifying. -3 squared, well, that's just 9. Because negative times negative makes a positive. Okay, this one, we've got a -1 plus 4. That gives us a +3 squared. That one's also 9. So I've got 9 plus 9, which is 18. So this distance equals the square root of 18. Now, 18 is not a perfect square like 25, but it has a perfect square hiding in it. Okay, the perfect square hiding in 18 is 9. So I can break apart root 18 into root 9 times root 2. 9 times 2 is 18. Now I know that the square root of 9 is 3. So I can say that this is 3 root 2. So that is my JK. So my JK is 3 root 2. So 5 and 3 root 2 are not the same. So I'm going to say that these are not congruent. Let's do it down here. So FG is not congruent to J. Okay. Because their measures are not the same. All right, let's try another one. G's. Okay, EF and GH. Okay, that's this one. And GH is this one. Holy cow. All right, we can do it. Okay. I'm going to do this one in a different color. This one's going to be my pink one. Let's start with EF. Okay, so the coordinates for E are -2, 1. And the coordinates for F are -5, 5. Okay, let's find the distance. Distance equals the square root of my y sub 2, which we start with the x's and the y's. It doesn't really matter because we're adding, but I don't want to confuse everybody. Let's start with the x's. Sounds good. Great. Okay, perfect. So we'll do -5 minus -2 makes a plus. And we square it, plus. Okay. My 5, my y sub 2 minus 1. That was my y sub 1, and square it. Okay, now we're going to simplify. So -5 plus 2, that gives me -3. If I square a -3, I'm going to get a +9. 5 minus 1 is 4. 4 squared is 16. So 9 plus 16 is 25. So this distance is the square root of 25, which we know is a perfect square. It's 5. So that's my EF. I'm talking about its length, so I'm not going to put the segment bar over it. I'm talking about its measure. Okay, let's find the GH one. Okay, so G is at -1, 2, and H is at 1, nope, 3, 1. Okay, so my distance is the square root of, I liked it better when I labeled these, so I'm going to go back to that. Here's my x sub 1, y sub 1, x sub 2, y sub 2. Plug them in. So my x sub 2 is 3. So I want 3 minus my -1, which turns to plus. Square that. Plus. My y sub 2 is 1. Minus my y sub 1 is 2. Square that. Okay, let's simplify. 3 plus 1 makes 4. Square 4 and I get 16. 1 minus 2 is 1. Nope. -1. Oh, guys. I made a mistake. Look at this point G. It's at -1, -2. Would you add a negative on this 2 right there? Okay, so when I plug that in, I should get minus a -2 squared. And that's going to be a plus. All right, back to simplifying. 1 plus 2 is 3. Square that and I get 9. We already know that 16 and 9 make 25, so this distance is the square root of 25, and that is my GH. So I know that EF, the segment, is congruent to GH, the segment, because EF equals GH. And that comes from the definition of congruent. Okay. Yeehaw. Next. Okay, in a right triangle, the two sides that form the right angle are the legs. We already know that. The side across from the right angle that stretches from one leg to another is the hypotenuse. We already know that. In the diagram, A and B are the lengths of the shorter sides or legs, and the longest side, the hypotenuse, is C. Okay, so you probably heard the Pythagorean theorem when you were in middle school. We're going to use it again. So this is basically just kind of the same thing as the distance formula. Okay, if I want to find the distance from D to E, I can make a right triangle and give it legs A and B. So my length A, you can just see, goes from -2 to +3, and that's 5 units. 1, 2, 3, 4, 5. So my A is 5. Okay, my B goes from -5 all the way up to +4. That'll be 9 units. It's 9. I hope. Geez, is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, holy crap. Okay. So I just have to find my C. So I know that A squared plus B squared is C squared. Well, I know what my A is. I said it was 5. 5 squared. My B was 9. So plus 9 squared has to equal my C squared. So now we just get to do some simplifying. 5 squared is 25. 9 squared is 81. 25 plus 81. You better be getting your calculator out too. I want to say it's 106, but I've been here too long today. 81 plus 25. Yeah, it's 106. Okay. Yay, mental math. Okay, so my C squared is 106. Now, right now, my C is squared. I don't want it to be squared. I just want regular C. So you might remember from Algebra 1 that we undo squaring by taking the square root. Okay, now if I'm finding a length or a distance, I don't care about the negative square root. I just want the positive one. So I don't really care about the minus one. I'm just going to find the principal root because I'm after the length. And it says that I can go to the nearest tenth, so I'm just going to use my calculator for that. Power 0.5. All right, it says that my C is 10.2956, yada, yada, yada. And I want the nearest tenth, so let's talk about rounding. Okay, the nearest tenth is this decimal place. So what I'm asking is, do I stay at 2, or is 9 so big that I have to move up to 10.3? And 9 is big, so I'm going to go to 10.3. So my C equals 10.3. So basically it's 5 up, 5 and up, and we round up, 4 and down, and we hit the floor or something. Okay, that's it. That's all we had to do. Let's do another one. Okay. It looks like my A is 6 and my B is 3. So my 6 squared plus my 3 squared should give me my C squared, which is my hypotenuse squared. So 6 squared is 36. 3 squared is 9. 36 plus 9, that is 45, is my C squared. Now, I don't want my C squared, I want my C. So I have to undo the squaring on both sides by taking the square root. And these directions again say that I'm rounding to the nearest tenth. So I'm going to take the square root of both sides. Lengths and distances are always positive, so I just want the principal root. That's the positive one. I don't care about the negative one right now. Remember when you were solving quadratics? We had to let the quadratic, the parabola cross the x-axis in 2 places, so we had to let it be the positive root and the negative root to find both solutions. We don't have to worry about that here because we're just after a length. All right, so let's figure out what square root of 45 is to the nearest tenth. Okay, so I'm getting C equals 6.708, yada, yada, yada. I don't care about all that. I just want the nearest tenth. Okay, 0 is very, very low. So I'm going to stay at 6.7 instead of rounding up to 6.8. So I'm going to say C is 6.7. Let's try another one. Okay, my A is 1, 2, 3, 4. Is that 6 again? 6. That's also 6. Okay, so 6 squared plus 6 squared equals my C squared, my hypotenuse squared. That's 36 plus 36 for my C squared. 36 and 36 make 72. Okay, but I don't really want C squared, I just want C, so I'm going to have to take the square root of both sides. It just occurred to me that I should probably show you how to do this on the calculator in case you forgot. So let me pull up my calculator on the board and I will show you. Okay, welcome back. So what was it? The square root of 72? Okay, the square root button is here. Okay, it's right above the x squared button and it's in blue. So in order to hit that, we have to hit the second button first. Okay, so like the second square root and then put a 72 under there. Oh, this is great. Now we can talk about rounding on here. Okay, so if I'm rounding to the nearest tenth, I have to decide if I stay at 8.4 or if 8 is big enough to send me to 8.5. Now 8 is 5 or bigger, so I'm going to go to 8.5. That's going to be my nearest tenth. So my C is 8.5. That's it. I guess for these guys, we can take our pick if we want to use the distance formula or the Pythagorean theorem. I've always liked the Pythagorean theorem better because it feels less like struggling. Okay, so if I'm thinking of like a side going from 3 to 9, that side is going to be 6 units long. So my side that's going from 3 to 9, that's my A of 6. Okay. My side that goes from 8 to 10, that's my other leg, and it's going to be my B, and it's 2. So if I use the Pythagorean theorem, I'm going to do 6 squared plus 2 squared, and I'll get my C squared. Okay, well, 6 squared is 36. 2 squared is 4. Not 40, 4. I added them in my head. I went ahead a step. Okay, and then 36 plus 4 is, of course, 40. Okay, now we can take the square root of both sides. Boo, boo. We just want the principal root, so we don't care about the negative square root. And it doesn't say on this one that we get to round to the nearest tenth, so we have to find the biggest perfect square or factor hiding in 40. Okay, so I'm thinking about it, and I see a root 4 in there multiplied with a root 10 for my C. Well, the square root of 4 is 2, so that simplifies to 2 root 10 is my hypotenuse C. I guess we just get to do the same thing, huh? Okay, now this one's a little bit more challenging because it's got negatives, but we're going to do the exact same thing. So my leg that's on for my x coordinates, it's going from -2 to -6. Those are 4 units apart. Okay, so my A has to be 4. I don't care if it's going left 4 or right 4 because my A is a length. Okay, so I'm just going to call it +4. Okay, my side B, my other leg, is going from 2 all the way to -8. That's going to take a leg that's 10 units long because it's got to go from 2 to 0 and then 8 more to get down to -8. Okay, so my B is 10. Okay, so my A squared is 4 squared and my B squared is 10 squared to give me my C squared. So that's 16 plus 100, geez Louise, equals C squared. That gives me 116. Holy Hannah. Okay, now we got to take the square root. I just want the positive one. I don't care about the negative one because my side has to be positive. It's a length or a distance. All right, we got to try some perfect square factors. All right, you're probably going to have one of these. Okay, these are the perfect squares and perfect cubes. Okay, so I'm going to start with 100. 100 is on my list, but it's too big to go into 116 evenly. So it's 81 and probably 64. Yeah, 64 does not go in evenly. 49 won't. Let's try 36. 116 divided by 36. Nope. 25. Nope. 9. Probably not. No, it won't. The biggest perfect square inside of 116 is 4, guys. So 116 divided by 4 is 29. Gross. Okay, so this is root 4 times root 29. That's my C. We know the square root of 4 is 2. So this is 2 root 29. Ooh, yikes. That's it.